In the last episode of our series on limits, we learned that limits are all about x approaching a number. No matter what number we're talking about, limits are always about approaching. Though one of the most important parts we must come to grips with about limits is actually that there are two kinds of limits. The first is one-sided limits, and the other is two-sided limits. And though they may be similar, it is important that we distinguish between these two. So like anything that has a different meaning in math, of course, one-sided limits are going to have a different notation than two-sided limits. Let's compare. So we're already familiar with the two-sided limit. That would be if I just said limit as x approaches a number. We should already be pretty used to that by this point. However, where one-sided limits shine is actually that they're a little bit more specific. And there's actually two parts in this one category. The first, of course, is the left-sided limit. And it's represented with limit as x approaches a number. Okay, up to this point, very similar. But herein lies the one key difference, and that is with a superscript minus sign. Now, as the sign suggests, just like if this green line was x equals 0, the left-handed limit comes from the left side. Now, it doesn't mean it's only negative, right? Because you could also have a left-sided limit on the right side as well. Just to clarify, I'm sorry for the confusion. I meant to say that you can have positive left-sided limits too, not that you have left-sided limits on the right side. That's not right. But back to the video. But really what it's about is basically what direction are you coming from? In this case, the left-hand limit says that we need to come from the left, right? The negative direction. And naturally, that would also mean we have a right-handed limit. Again, same as before, but this time, the superscript is a positive sign. And that basically flips the entire script, where instead of going from negative to positive, it's having us go from positive to negative. But all in all, the concept between one-sided and two-sided limits are exactly the same. The only difference is that left and right limits are a little bit more specific. Now, I know it may seem a little redundant that we have one-sided limits and two-sided limits. So why is it that we have two different kinds of limits? Well, the answer really isn't that scary, and basically the whole point is that a one-sided limit brings clarity to the two-sided limit. Think of it more as that the one-sided limit completes the two-sided limit, not is redundant to it. And as we'll see in just a moment, suppose we have a function. There may be moments where it has either one or both one-sided limits, but it may not have a two-sided limit. But we can see this behavior in a variety of different graphs. So what would be an example of that? The first example of something like this happening is with an asymptote. But an asymptote kind of looks something like this. This red line is the function 1 over x. And the asymptote, really, it's not what's on the graph, it's actually what the graph is lacking. And you'll notice that the line never actually touches the y-axis. Now, it's not the best time to talk about continuity, that we're going to talk about in the very soon future. But I want to emphasize the limit. In this particular instance, what does it look like? Again, the y-axis is where x equals 0. If we try to say limit as x approaches 0 of our function, there's a bit of a problem. Because look at this, if we approach from the left, the line very clearly drops all the way down. And in fact, it drops all the way down to negative infinity. But the problem is if we come from the right, it doesn't go to negative infinity, no, it actually goes up all the way. So the answer isn't negative infinity either. It should simultaneously be negative infinity and positive infinity. Now that doesn't really make sense because for a limit, the idea is that it needs to approach, as we've said this before, it needs to approach one specific number. Now clearly, negative infinity and infinity are not numbers, but we can see an approaching to it. It never stops getting bigger and bigger and bigger. And we know that if one input provides two outputs, then that's not a function. And so that's basically what the left and right-sided limit tries to solve. Is instead of trying to generalize the limit of the entire function, we can say, well, as we approach from one direction, it becomes one number, and if it approaches from a different direction, it's a different number. So now that we were able to get a little bit more clarification on the asymptote, there's another kind that we want to look at, and that is a jump. Now we'll go, again, more into detail in our continuity video. This is not relevant to what we're talking about, but we would also see a similar problem that happened up here if we had some kind of jump in our problem. Now, as you can clearly see here, there isn't an infinite gap in between the end of this line and the end of this line. But a similar problem occurs. If I try to approach, let's say this is x equals 2. If I try to approach x equals 2 from the left, I would say that gives me about y equals 2. But if I tried to approach x equals 2 from the right, I would get a value of y equals 3. And again, limits by themselves cannot approach two different values. And yet, this is another reason why left and right-handed limits are so important. And the last example we'll look at is a restricted domain function. Now for this function, I tried to sketch out the square root of x plus 1. Now hopefully you could see the problem pretty apparent here. Let's say this is x equals -1. Obviously, approaching from the right, our y value approaches 0. But if I were to try to approach from the left, what do I have? Well, the function is basically non-existent on this side. There's basically nothing we can do on that side. So in this case, if it was just a normal limit, it would simultaneously equal -1 and does not exist. And again, just like in the other problems, there cannot be two contradictory answers. So hopefully what we've seen here will clarify the entire point of one-sided versus two-sided limits. So the first example we have here is the function f of x equals x over x minus 3. And on this function, you can clearly see there is an asymptote at the value x equals 3. So this one problem that we have has three distinct parts. First, we need to ask, what is the limit as x approaches 3 from the left? The second is, what is our limit as x approaches 3 from the right? And last but not least, what is the limit as x approaches 3 of our function? Let's take a look at the first one. Now when it says from the left, it doesn't mean we're going left. Now remember, we're approaching 3, but the side is specifically from the left. Notice how our function gets closer and closer to the asymptote, but it never actually touches the asymptote. The distance between the asymptote and the line gets closer and closer. Now in practice, we can't actually ever get to x equals 3. But in theory, if we were trying to imagine what it would be like if we went infinitely far, we would be able to get x equals 3. So as our x approaches 3 from the left, our y value approaches -infinity. Because again, it'll never actually get to 3, it only approaches 3. Now how about the second one? Now just like last time, it doesn't mean we're heading right. No, it means that we're starting from the right, or numbers that are bigger than 3. And so let's do the exact same thing that we did for the left side. As we get closer and closer to 3, what happens to our y value? Again, it can never touch the asymptote, so in practice it will never get there, but theoretically, if we went infinitely far away, then we would get to x equals 3. But in this case, it doesn't reach to -infinity, no, it goes all the way up, meaning it reaches positive infinity. And this last one is our two-sided limit. Now this one's the trickiest, because now we have to consider both directions. But here's the problem. If I come from the left, it goes to -infinity, and if I come from the right, it goes to positive infinity. So what does the limit equal? Well, as I demonstrated earlier, if there are two contradicting answers in the one-sided limits, then what that means is that the two-sided limit does not exist. Another instance when we might see a similar behavior is when we have jump discontinuities, like we see in this piecewise function. Now, if you want to learn the different kinds of functions that there are, please let me know down in the comments below. I'd be happy to make another video on that. But for this function in particular, I broke it down into 3 parts. Y equals 3 when x is less than or equal to -1. Y equals x squared minus 1 when x is between -1 and 2. And lastly, y equals -x plus 7 when x is greater than 2. And just like last time, we need to ask the same questions. How about this time, let's do it from x equals -1. So let's focus on this part first. Remember, it's not going left, we're not going left, it's from the direction of left. So what we're trying to do is get closer to -1 on the left side. Now what does it seem like our limit is approaching as x approaches -1 from the left? Well, since it's a flat line, it's a constant, meaning no matter what value of x you pick, it's gonna stay at that same value, which as we see in our function is y equals 3, so the limit as x approaches -1 from the left, again pay attention to the negative, equals 3. Okay, how about from the right? Well, again, we're not going right, that's not what's happening. Instead, what we're doing is picking numbers to the right of -1. And so that would be this part of the function right here, the parabola shape. But now pay attention here. Unlike last time, it doesn't approach 3 like we said from the left. No, as a matter of fact, if we're approaching from the right, what does it seem like it's approaching? Well, in this case, it's approaching 0. So there is yet another contradiction in the left and right hand limits. Not a good sign. So what does that mean the only option for our double-sided limit is? Well, since they're contradicting answers, that means the limit as x approaches -1 of our function does not exist. And so the space in between doesn't have to be from -infinity to infinity. It is very cut and dry. If the left and right hand limits do not match, then our two-sided limit does not exist. And that's that. There's no other options for it. And lastly, we're going to take a look at this function right here, which is y equals log x. And I'll ask the same questions again. Well, some things to recall from earlier is that we do have an asymptote right here. It's that dotted green line on the y-axis. But the more important part is that it is on a restricted domain. This is really important to get down. Just because there's an asymptote, that does not mean the limit is undefined. Okay, rather, what makes this limit undefined? Let's start with the right. Limit as x approaches 0 from the right. Obviously, we're approaching 0 from the right-hand side, and it goes down along the asymptote to -infinity. So it should be pretty obvious at this point, in order to get to 0, you have to be infinitely far away, and in this case, it's in the negative direction. But the limit as x approaches 0 from the left is a completely different story. Because what happens? As you approach 0 from the left, what happens to our function? Well, as you can clearly see, there is no function whatsoever. It's totally blank. And so, if there's no function, is it possible for there to be a limit where there is no function? Well, absolutely not. And so, the limit as x approaches 0 from the left also does not exist. Now, this is the thing to drive home. It's not the fact that there is an asymptote. It's the fact that the left and the right-hand limits do not agree. That means that the limit as x approaches 0 does not exist. Let me say that one more time. It has nothing to do with the asymptote. It has everything to do with the fact that the left and right-hand limits do not agree with each other. So what are the key takeaways of our topic today? Well, we know that limits are all about x, whatever variable, approaching a number. By definition, that's all a limit is. But in order to have more clarity, we need to understand that there is both a left-handed limit and a right-handed limit, and that if you want a two-sided limit like we have up here, they must agree with each other. And remember, the direction signs tell us what side of the target number to be on, not what direction to go. And really at the end of it, left and right-handed limits are not a completely new topic. No, it's an extension of what we already knew. So keep it up, continue practicing, you're doing great.